Assalamualaikum and hi to all my panel. Today I will presenting my Bachelor Degree Project 1 with the title Evaluation of neem and papaya leaf extract as an eco-friendly corrosion inhibitor for carbon steel in 0.5 mol hydrochloric acid medium. My name is Sofea Anissa binti RIZAL PAHLEPI B0918107172. My supervisor is Dr. Muhammad bin Muhammad. This is my agenda presenting, which is introduction, literature review, research methodology, and expected result. For the background of the study is, carbon steel typically have a carbon content of 1.5% or less, as well as trace amount of manganese, silicon, phosphorus, and sulfur. Corrosion is one of the problems that carbon steel face as a result of poor protection. In addition, corrosion is the wear and tear caused by chemical reaction, most notably oxidation. A corrosion inhibitor is a chemical compound which, when released into the environment, can slow the rate of the metal corrosion. The green corrosion inhibitors are biodegradable corrosion inhibitors that are devoid of heavy metals, chemical, and some hazardous substances. For the problem of statement of the study, the corrosion process is among the most damaging process, producing massive economic damage in the automotive, marine, oil and gas, and aerospace sector. Accordingly, the implementing of inhibitor for corrosion safely in marine and acidic environment as well as good protection for metals. Otherwise, the most common use is organic inhibitor. The use of inhibitor could be well-known strategy once metal corrosion has to be prevented, controlled, or reversed. The inhibitors are expensive, poisonous, and harmful. Furthermore, in this study, we will use green inhibitor because they are the least expensive, biodegradable, ecological acceptable, and renewable. In the form of the circular economy, the valorization widen potential use in manufacturing field other than waste of the energy. For the objective of this study, they have three: to investigate the influence of the immersion period on the inhibitor efficiency of the green inhibitors. Secondly, to evaluate the inhibitor efficiency of neem and papaya leaf as plant-based green inhibitor for low carbon steel in seawater and acidic medium. Thirdly, to compare the performance of the selected green inhibitor in preventing corrosion in low carbon steel. Now, I will explain the scope of the study. There is 9 scope of the study. Firstly, to study the base formulation of the green inhibitor to perform as anti-corrosion performance of the inhibitor on a low carbon steel substrate. Secondly, selection of suitable plant to be extract as organic inhibitor. Thirdly, preparation of plant-based green organic inhibitor for extraction. And thirdly, the substrate will cut into ADM machine and the thickness is 5 mm. Fifth, the hardness of test and optical microscope to perform a mechanical testing on the substrates. And next, perform the corrosion test on the base metal that was inhibited by the corrosion inhibitor, that is neem and papaya leaf, to study the corrosion behavior via an emission test in 0.5 mol HCl. The sample will divide into a 3 group, of which have a 6 sample immersed in 0.5 mol HCl and another 12 sample will be immersed in 0.5 mol HCl with different inhibitor. For the lastly is using SCM or EDX to study the corrosion behavior on the substrate after a test. For the carbon steel, there is 3 types of carbon steel. Firstly, high carbon steel, medium carbon steel, and low carbon steel. There is a various property of carbon steel, and the highest carbon is high carbon steel. For the low carbon steel, the advantage is weldable. Low carbon steel is typically the most readily welded, easy to shape or cut, cheap. The low cost of the weld is effectively for the low carbon steel. For the application is automotive, shipbuilding, oil and gas, which is pressure vessel and tank. For the overview of the corrosion, what is corrosion? Based on the Kadim and Franz, corrosion is defined as metal and other failure induced by chemical or electrochemical exposure to the environment. We can see in the picture below. The corrosion also is the process of degradation of metal property through an unwanted chemical or electrochemical attack by its environment. The factor of the corrosion is relative humidity, temperature, and air pollution. There is two form of corrosion, which is uniform and localized corrosion. The uniform corrosion is the uniform corrosion. For the localized corrosion is galvanic corrosion, atmospheric corrosion, heating corrosion, crevasse corrosion, erosion corrosion, and other. For the corrosion protection method, actually we have 5: protective coating, cathodic anodic protection, environment modification, which is inhibitor, the material selection. We need to select the right material selection and proper design. Next, I will compare the two inhibitor. Corrosion inhibitor is a chemical substance that, when applied in a small amount to a corroding environment, reduce delay of preventing metal corrosion. The inorganic inhibitor and organic inhibitor. Organic inhibitor is eco-friendly and non-toxic, cheap and readily available, environmental friendly compared to inorganic inhibitor. For the plant-based green inhibitor. Firstly, plant-based ester as an organic species have therefore become vital as an environmentally acceptable, quickly on the market and sustainably sourced for a variety of application inhibitor. For example, aloe vera, turmeric, orange, and banana. The term of green inhibitor or eco-friendly inhibitor is allude to biocompatible substance found in nature. And there is non-toxic, economic, and readily available. For my research of the previous study for other plant, there is molasses, hipsters, they use many substrate, which is mild steel, low carbon steel, and chemical concentrate is hydrochloric acid and other more. This also is the previous study that I find Carica papaya, Musa paderesca, Lingularia fisheria. Next, I will use neem leaf inhibitor as my study. For the scientific name of neem is Anzadiacta indica neem, a part for the Meliaceae family. Anzadiacta indica contains a complex constituent such as nimbin, nibidine, nibolidine, and limonides. And this component play a significant role for disease control. For the Anzadiacta, this is the research that the substrate used is carbon steel, mild steel, zinc, and copper that were immersed in HCl, chloride medium. Okay, this also I will use in this study. There is papaya leaf inhibitor. The scientific name is Carica papaya leaf. It's a member of the Cariaceae family. Papaya leaf extract made from dry and fresh ground leaf contain a variety of compounds, including flavonoids and other plant phenols. This is the research of this study for the papaya leaf that use copper, mild steel, and chemical concentrate is hydrochloric acid, sodium hydroxide. So I will explain the flowchart of this study. Firstly, we prepare the specimen, which is low carbon steel with diameter 20 mm and thickness 5 mm. Next, the preparation of corrosion medium, which is neem leaf solution and papaya leaf solution, go to extraction process, oven process, FTIR, immersion test, and for the low carbon steel, we use mechanical test for substrate and for the micro hardness analysis and the microstructure analysis. After the process, we submit the thesis. For the material sample, we use low carbon steel and substrate dimension, which is 20 mm and 5 mm. The material preparation according to ASTM G1. For the inhibitor preparation for neem leaf extract, firstly, tie the neem leaf into a small piece and then dry it under environmental condition, then boil it with distilled water, then extract insert the rotary evaporator, evaporate extract without water composition, then extract, then insert into the oven, then finally the liquid form. For the inhibitor preparation for papaya leaf, also same with the with the neem leaf. Firstly, tie the papaya leaf into the small piece, dry it under environment condition. Then the leaf will be ground into a powder. The extract then insert into the rotary evaporator, and lastly the extract liquid form. For the mechanical testing of the substrates, which is low carbon steel, we use optical microscope, grinding and polishing machine, and hardness testing machine. We use to examine the microstructure and the hardness of low carbon steel. For the material characterization, we also use SEM and EDX to analyze in detail the microstructure and the composition of the immersed substrate. For the quotient test, we divide for 4 quotient tests, which is quotient testing is to determine the quotient material resistant to environmental conditions such as temperature, humidity, and salt water. For the immersion test, immersion testing is the most often used technique for monitoring metal quotient in aqueous solution, which is hydrochloric acid, and the process of the quotient degradation caused by the length of the time exposed into corrosive atmosphere. We can see in the picture there is inhabited medium, low carbon steel specimen, stirring, and the container. Next, for the visual inspection, we use 3 samples: hydrochloric acid with neem leaf extract, hydrochloric acid with papaya extract, and lastly for the hydrochloric acid only. Each sample contains 6 low carbon steel specimens will be observed within 1, 2, 4, 6, and 8 weeks or 2 months. Next, for the quotient test weight loss measurement, there is a weight loss measurement will be carried out at various concentrations by immersing substrates in HCl solution, and the formula is W0 represents weight loss without the inhibitor and Wi denotes weight loss in the inhibitor. For the corrosion rate is the rate of the corrosion in the rate at which a specific metal deteriorates in extremely specific condition. And after doing all the things, the expected result of the study is the grain inhibitor mechanism. The corrosion protection diagram will be performed on the basis of the testing finding. Furthermore, this experiment will establish absorption on the low carbon steel substrate surface. As a result, we can see in the picture, there's a low carbon steel with a protective film that the chemical molecule in neem and papaya leaf may form a coordination bonds. As a result, the inhibitor will produce durable barrier layer, which is protective film, and block low carbon steel process at 0.5 mol hydrochloric acid. Next, expected result of weight loss and corrosion rate. Weight loss will be observed to compute the loss of weight in the specimen pre and post immersion, whether the weight of loss could increase or decrease with 3 solutions, neem and papaya, and 0.5 mol HCl. The corrosion rate is the rate of any metal degrade in acidity specific environment. We can see in the graph of weight loss measurement and the corrosion rate. This is the Gantt chart for PSM1 within week 1 until week 16, and the activity from the supervisor selection until the preparation and presentation of PSM1 for the smoothness, completeness of the thesis. This is the Gantt chart that I will plan for the next sem. This is the several reference of this study from many researchers. And I will end the presenting with thank you.